Okay, guys, so now we're gonna take a look at another problem, the same tree problem. So I think the title is pretty self-explanatory. We have two trees, and we're gonna check if they're equal or not. So just as a reminder, a tree is a data structure composed of nodes. Nodes, you can represent them as these circles here. And each node has a left pointer, a left reference, and a right reference, and it has its own value. And here in this problem is defined by the constructor init. So I'm gonna explain now the approach you can take to solve these problems. As usual, trees should ring a bell to you guys. Tree reminds you should remind you of recursion. In recursion, we always start with the basic, the simplest scenarios, and then we work our way through the harder problem we're actually trying to solve. So let's suppose the tree is just, both trees are empty. So you're giving two references to the trees, P and Q, as you can see here. So suppose you're giving two references to two trees and both are empty. Are they equal or not? Well, if both of them are non-existent, it's true, they are equal because they don't exist, right? So in this scenario, it would be true. So let's code this. I'm gonna erase this. So if P equals none and Q equals none, it's true. You return true. Because they don't exist, both don't exist. It's useless, but it's true, right? So let's now look at a second scenario when you're giving two trees, one is empty and the other is not empty. Well, they're not equal, right? Because here you have a node with a value of 3, and in the other it's empty. So in this scenario, in this case, this will be false. Since we already checked for the case where both are none, I'm gonna just check if either P is none or Q is none. This wouldn't work if I hadn't checked previously for the case where both are none. But since we already checked for that, here we're gonna just check if one of them is none and the other by default is gonna exist because, as I said, we already checked if both of them are none. And in this scenario, it is false because, as I mentioned, you have a node and you have an empty tree. The third case, we have two nodes, but in this case, three is what the node of the P tree is 3, the value is 3, and of the Q node, the value is 4. So although they do have the same structure, their values are different. And we're not only looking for structure here, we're looking also for the values. So they should have the same shape as we have here, and also the same values. So else if p.val is different from q.val, we have false. And finally, our last case is when the shit is real, where where we're actually solving the problem. And here we have two trees. You're gonna be given a P, reference P, reference Q, reference Q, okay, reference Q, and we're suppose so you're gonna as common sense, we know we're gonna check this and compare to this and compare to this, and this and compare to this, right? But suppose we're just comparing these shoes, this shoe. The trees will be true if both the left part of the tree, the right part of the tree, the left part of the tree, and the right part of the tree are equal. So if these two are equal, then it's true. Then the tree is true. So that's what we're gonna check here. So return, but you're gonna call it recursively. P dot left, Q dot left, and here you call the function with self. But it doesn't really matter. It's just what matters that we're calling. So what we're doing is recursively checking if both the left side of the tree and the right side of the tree are equal. So let's go through the recursion, you guys understand. So we're currently at P and at Q. None of these scenarios are true, so none of both of them exist, so they're not none. Also here is not true, and the value of them are equal, so we're not gonna fall on this. So you're gonna call the recursion with SameTree P dot left Q dot left. So you're gonna go to the left, and now you're gonna call the function with 2 and 2. Okay, so you're gonna call SameTrue, but now P will be like this, P will be here, and Q will be here. And uh, same thing, they will be called again. But they're gonna be called as if they were trees with just one node. Then you're gonna, none of these conditions will be true, and you're gonna also call the recursion. Same tree, P dot left, Q dot left. But P, oops, this was not porn. This was a music song. If you thought it was porn. But to the left and to the left will be none. It's gonna return true. And since the recursion call is an AND, this will be true. This will be true, and then you're gonna call SameTree with P dot right, Q dot right. We're gonna check the right side is gonna be none true, so true and true are true, and 2 will return true. 2 will return 2, and this will return true as well. Then we're gonna go to the right, we're gonna check 3 and 3, go to the left, go to the right, they return both true. 3 will be true, and this will be true. And then true will be true, and return true. I know it sounds, if you don't understand recursion, probably what I'm talking about is doesn't make any sense. So again, this is a hard problem. If you're confused about recursion, look at some tutorial, practice some problems, and then you understand what this is about. Uh, but it's pretty interesting because again, what we're doing is always checking for the basic scenarios and then apply those basic scenarios to the larger problem. If you always use this model, this blueprint to solve recursion problems, it should be easier. But those are hard problems. You have to actually work through them. That's one of the reasons why I'm doing this tutorial. So yeah, guys, if you have any questions, if you want to give me any feedback, just put down in the comments and I'll be more than happy to answer. Thank you.